Is achieving a basic skill level related to the location of the school? The results of a random sample of students by the location of school and the number of students achieving basic skill levels in 3 subjects is shown in the contingency table. At alpha equals 0.01, test the hypothesis that the variables are independent. Alright, the first thing that we need to do in this particular problem is identify the claim and state the null and alternative hypothesis. So, the null hypothesis, which is always a statement of equality, in this particular case is dealing with the claim. And that is the skill level in a subject is independent of location. And then the alternative hypothesis will be that skill level in a subject is dependent on location. In this particular case, the null hypothesis is the claim. The next thing that we need to do is determine the degrees of freedom, find the critical value, and identify the rejection region. So part B, degrees of freedom. Well, in this particular case, for degrees of freedom is equal to the following formula. And we're going to have R minus 1 times C minus 1. And this is going to be based off of the table. R is going to be the number of rows, and C will be the number of columns. And in this particular case, for the number of rows, we will have 2. And the number of columns, we will have 3. Therefore, our degrees of freedom will be equal to the following: 2 minus 1 times 3 minus 1, which is going to be equal to 1 times 2. So our degrees of freedom will be 2, and that's what we'll be using when we go into the Chi-Square table. Now we know that this is going to be a right-tailed test, and we're going to use the following graphic from the Chi-Square distribution table. So we note that this is the rejection region, and if we calculate a statistic that falls above the chosen Chi-Square value, then we will reject the null. If it falls below that, then we will fail to reject. So now with degrees of freedom 2, and at the significance level of alpha is equal to 0.01, well, here's the row for degrees of freedom of 2. Here's our alpha of 0.01, so therefore we know that the Chi-Square value is equal to 9.210. And that's what this value is going to be. And anything that's less than that value, we will fail to reject. Now, what we want to do is go ahead and decide what sort of inequality we can use to represent this. Well, we know that this Chi-Square here is actually my Chi-Square naught, or my critical value. I could look at it as the calculated Chi-Square is going to have to be greater than my critical value, Chi-squared naught, in order to reject the null hypothesis. Now comes the fun part, is going ahead and calculating the Chi-square value, or the test statistic, for this particular problem. We're going to use statcrunch to do this. So part C, the problem for this though is the way the contingency table is set up. We would normally go ahead and left click on this and then open it in statcrunch. But we can't use the contingency table the way it's set up in statcrunch. So we're going to have to modify it. We're going to go ahead and rearrange the rows so that they are now columns. And so we would have urban and suburban. And then we're going to put the subjects down the side, which will be reading, math, and science. And then we're going to have to make sure that we put the correct values into our newly formed table. And you can just double check and make sure that you see that it is the same table, just in a different format. So now we'll go ahead and bring up statcrunch, and we're going to go ahead and input this table. So right here, I'm going to go ahead and type in subject. Okay, so now that you see what we've got, and left click stat, we'll go to tables, contingency with summary. We're going to select both the subject, we're going to select urban, and we're going to select suburban. And then we'll select under row labels, subject, and that's really all we need to do. So we'll left click compute, and that's going to give us this table. And you'll notice down here that it's got the chi-square value with 2 degrees of freedom being 0.78579, which will round to 0.786. Now that we've calculated our test statistic and know exactly what that value is, we can go back up and we can look at the fact that in our rejection region, it's going to be greater than this value right here. But the value of 0.786 is going to be somewhere right down here. Therefore, we fail to reject the null hypothesis. Which means that if we put this in words for the last part, we will fail to reject the null hypothesis, and we will report there is not enough evidence to reject the claim that skill level in a subject is independent of location.